So on 8-35, examine the two types of investments, simple interest and compound interest. So on the first one, we're starting with 1,000. We have 1,080, 1,160, 1,240. So in this situation, it looks like we are adding 80. So that's going to make this arithmetic. So they want us to write an explicit equation for this. So this is going to be y equal 1,000. I'm adding 80. Now this is where I need to be careful. This is my first term. So if that's your first term, you're going to write x minus 1. Or you need to go backwards and find the term before this, which would be your zero term. And so that would have been, so we're adding 80, that would have been 920 times, sorry, not times, adding, plus 80x. These are the same equation. On B, consider the next one. So the next one, what we're doing is we are not adding. I'm going to take 1,080 divided by the second term divided by the first term. So I'm going to take 1,080 divided by 1,000, which is going to give me 1.08. So I am multiplying by 1.08. Okay, so we're multiplying by 1.08. So that makes this geometric. So this one's going to be y is equal to 1,000 times 1.08. And again, this is your first term, not your zero term. So you would go x minus 1 if you're going to start with your first term. Or if you're going to start with your zero, we need to go backwards and see what was it before this. So basically, I would take 1,000. I would divide it by 1.08 if I'm going backwards. And I'd have 925 point, let's say 92. So about 925.9, I'll push up to 93 times 1.08 to the power x. How could the sequences in part A and B represent investments? So A, when we're adding 80 each time, would be simple interest. Because we're adding the same amount every time. And what we're doing is, if you were to take 80 out of 1,000, you would see that we're getting 8%. So simple interest, 8%. So we're getting 8% of 1,000 every single year. B, when we are multiplying by 1.08 each time, that one is giving us compound interest. And again, that's 8%, but it's compound interest. Think about the graphs of both arithmetic and geometric sequences. Can your knowledge of the shapes of the graphs help you choose which investment to make? So if I was to draw these, A is going to be linear. B is going to be exponential. And so this one is going to grow faster. So you're going to I would pick the exponential because it's going to grow faster. So on this one, We have two sequences. They want us to interpret them as yearly account balances. Is the investment growing with simple interest or compound interest? What's the annual interest rate? Write an explicit equation for each. So in this situation, looking at this, it doesn't look like we're adding. So what I'm going to do is I'm going to take my 8,427, my second term, divide it by 7,950 to see what we get. So 8,427 divided by 7,950 gives us 1.06. Okay. So that means that it's 6% compound interest. And our equation would be y is equal to, and I'm going to start with 7,950 times 1.06. And where I have to be careful is this is the first one. So I'm going to raise it to the x minus 1, or I need to go backwards. Okay, or I need to go backwards. And so if you're going to go backwards, okay, then I need to take 7,950 and divide it by 1.06. And I'm going to get 7,500 times 1.06 to the power x. Now, for the next one, we're going to be starting with 300 and then 312 through 24. So we are adding 12. So this is going to be simple interest. And I need to figure out what the simple interest is. So I'm going to see what percent is 12 of 300. So 12 divided by 300, that shows me what percent of it. That is 0.04. So 4% simple interest. So for this one, we'd have y is equal to 300 times, sorry, not times, we're adding simple interest, plus 4% of 300, which is 12, and x minus 1, since this is my first term, not my 0. Or go backwards, subtract 12, and I'd have y is equal to 388 plus, sorry, 288 plus 12x. So the next one, so a third option for investing money is investing in a money market account, which offers to compound the interest more often. One example is a money market account that offers 8% annual interest compounded quarterly 4 times a year. This means that 8% is divided into 4 parts. This is kind of like our notes the other day. So that the bank pays 2% quarterly or every 3 months. So model this quarterly value. This is where you got to be careful. Pay attention to what their variables are representing. In this money market account with an equation, let y represent, okay, so we're going to let y represent the money in the account after x quarters. So x is quarters, not years. So you want to pay attention to that. Okay. So in this case, when we are doing this problem, we have $1,000, okay? And again, what they did was they took 8%, splitting it into 4 equal pieces, which is 2%. And when we take 100% plus 2%, we get 102%, which is 1.02 as a multiplier. So 1.02 to the power x, where x is quarters. Okay, so we got to be careful with that, not years. Use this model to calculate the value of your 1,000 investments after 4 years. So if it's 4 years, okay, you're getting it 4 times a year. For 4 years, you're going to have 16 times that you get the interest. So you're going to take 1,000 times 1.02 to the 16, because again, it was 4 times a year for 4 years. And so when we do that, put that in our calculator, 1,000 times 1.02 raised to the power 16, we're going to end up with $1,372.79. How does this compare with your investments in problem 8-32? So in this case, let's see, do we have 8-32 here? Okay, so I think they mean 8-35 or 8-35 here. So in this case, we're going to be getting more money because the 8% simple interest was the least amount. 8% compound interest was more, but if it's 8% compounded quarterly, that's going to be even more. So this is going to be the best situation. Okay, so this is going to be better than the other two. Which was 8% simple and 8% compounded annually. $8-38. You have $500 to invest and have several options available to you. Your banker shows you the graph at the right to explain what you can earn if you invest with him. Does this graph represent simple or compound interest? How can you tell? So since this is linear, this is going to be simple interest. Why? Because it's linear graph. And so that means we're getting a constant amount each time. What is the interest rate? Okay, so when we zoom in on this, okay, we have $500. Okay, so we're starting at $500. And then after a year, we're at 600 and then 700. So we are starting with 500. So we start with 500. And we are adding 100 each year. So I basically need to figure out 100 is what percent of 500. So I'm going to take 100 out of 500. So 100 divided by 500, divided by 500 is 0.2. 0.2, which means 20% simple interest. Okay, that's the percent. Now they wanted us to write an equation. So our equation is going to be y equal, we're starting with 500. We're adding 100. And in this case, since I'm starting at my 0, not at my 1, this is just going to be a plain old x. On B, Jerry says, I've got money in a grid account that compounds interest monthly. So compound interest monthly. Compounds interest monthly. The equation is y equal, so let me just get equation is y equal 388 times 1.008 to the power m, where which represents how much money I have at the end of any month. What is Jerry's annual interest rate? Write an equation to represent your total money if you invest your $500 in an account with the same rate of return. Okay, so in this situation, we need to, so this is how much he gets. So basically he has 0.008, which is going to be, I move my decimal 2 places, 0.8%. Okay, 0.8%. And this, he got 0.8% each month. So if I times this by 12, so if I take 0.8, whoops, let me clear this, 0.8 times 12, I end up with 9.6%. So this is going to be annual interest compounded monthly. Write an equation to represent your total money if you invest $500 times 1.008. Let m represent the number of months to the power m. So that would be our equation. So y equal 500 times 1.08 to the power m. Then on the next situation, an investment advisor shows you the table of earnings you see at the right. Write an equation for the table, letting Q represent the number of quarters. So this is quarters. Okay. What is the annual interest rate? So I'm going to take 515 divided by 500 to see what I'm timesing by. Okay. So 515 divided by 500 gives me 1.03. So we're multiplying by 1.03. So that means we have 3% each quarter. Now, if we have 3% each quarter, I'm going to take that 3% times 4 quarters and get 12% annual interest. Okay, so it's 3% each quarter. That means it's 12% annual interest. And they wanted us to write an equation for this. So it's going to be y is equal to 500 times 1.03 to the power q. Compare the earning potential of the options in parts A, B, and C above. Which account is the best investment if you plan to leave your money in for only 1 year? Which one after 10 years? Okay, so let me look at these situations. Okay, so the first one is 500 plus 100x. Okay, so 500 plus 100 x. Then we have 500 times, then we have 500 times 1.008 m, 1.008 to the m. And then we have 500 times 1.03 q. So then we have 500 times 1.03 q. So I'm going to plug in 1 year, let me make sure we understand this is 1 year. So in this case here, it would be 500 plus 100 times 1, which is going to be $600. Let me just draw a line separating it. Okay. So if I do 1 year here, that means that I'm going to have 500 times 1.008. Now it's 1 year. That means it's raised to the power 12 for 12 months. So let me put that into my calculator. 500 times 1.008. Wait, I think it was, let's double check. Yeah, just want to make sure I had enough zeros. 8 raised to the power 12. And so that is going to be 550 point. Let me just move this a little bit here. Okay, I guess it's not going to let me. Okay, so this is going to be 550.17. Okay, and 17 cents. So far that's the best for 1 year. And so this one for 1 year, I would have 500 times 1.03, and that's going to be to the power of 4 because there's 4 quarters in 1 year. So let's clear this and go 500 times 1.03 raised to the power of 4 because there's 4 quarters in a year. And so we get $562.75. So for the first year, the best one is this one here. Okay, so now let's do 10 years. Okay, so 10 years. So we're going to have 500 plus 100 times 10. So that is going to be 1,000 plus 50, which is going to be $1,500. Okay, so this one for 10 years. Now this is going to be 500 times 1.008. Now this is monthly. So it's going to be 12 times a year for 10 years. I'm going to raise it to 120. So I am going to have 500 times 1.008 raised to the power 120. And so we get 1,300 .87. Let me just make sure so 500 times 1.008 raised to the 120. Okay. And then the next one is going to be quarterly. So in this case, we're going to have 10 years. So we're going to have 500 times 1.03 for 10 years, 4 times a year for 10 years. I'm going to raise it to power 40. So I'm going to have 500 times 1.03 raised to the power 40. And we ended up with $1,631.02. So in this situation, for 10 years, the last one is the best. So hopefully this helps you guys out with doing exponential word problems.